Hi guys, welcome to your 12.4 notes on box and whisker plots. By the end of the day, you will be able to make and interpret box and whisker plots and to find quartiles and percentiles. If you haven't already, please do our intro activity following along with this video right here. Now that you've done that activity, let's go ahead and jump right into our key idea of the day. Separating data into subsets, that is a set smaller than itself. Separating data into subsets is a useful way to summarize, to get a summary for, to summarize and compare data sets. Because if you have a list of data, if you have one list that looks like this, you got a bunch of numbers and then another one, a bunch of numbers, it's hard to compare just by looking at a list. But if you had a nice way to break them up and to describe them, then you can compare them much more easily. So we will break these up, as you saw in our video, we will break them up into something called quartiles. Quartiles. Now a quartile, you see that quar in there? Quar you see also in a quarter. A quarter is 1/4 of something. So just like a quarter is a fourth, like a quarter is 25 cents, that's a fourth of a dollar. Or a quarter in a football game is 1/4 of the game. So quartiles are values that divide a data set into 4 equal parts. The first quartile is going to be found by finding the median of the lower half of the data. The second quartile is the same thing as the median, which we saw yesterday. The median is always going to be the middle number. So when we have the first quartile being the median of the lower half, we say median, it's the middle of the lower half. The third quartile then is the middle of not the lower half, but of the upper half of the data. And also a little note to you, if you are dealing with an odd number of values in your data set, then don't include the median when you're trying to find the third quartile and the first quartile. It's just a heads up. So another tool, another measurement that we use to describe a set of data is called the interquartile range. The interquartile range, or IQR, is the difference between Q1 and Q3. That is, we say IQR, the interquartile range, equals whatever the third quartile is, minus the first quartile. Let's look at an example. So here we have this set of data right here, and they want us to find the minimum, first quartile, median, third quartile, and maximum of these numbers. So our first thing that we should always do, our first step, is to arrange the data in order from least to greatest. So how I like to do that is I like to look for the smallest number. That seems to be 60. So I'll write 60, and then we have 65, and then the next smallest number is 75, and we have another 75, and yet another 75. Our next smallest number that hasn't been crossed off is 85. There's another 85, and still yet another 85. Our next smallest number is 95. Our next smallest number is 100. And then our last number is 105. So we have written all the numbers from least to greatest. Awesome. Now it's going to be a lot easier to see what's in the middle. Speaking of what's in the middle, our next step is to find the median. To find our median number, we can write it down on graph paper like you saw in the interactivity, or you can just cross them off from either side until 85. 85 is the median. Awesome. And now that we know what the median is, we can find our first quartile. Oh no. We can find our first quartile and we can find our third quartile. So now that we have the median, we're going to find quartile 1 and quartile 3. Now remember from above that we find the first quartile by finding the median of the lower half of the data. So let's look at just the lower half. Wait, do we have an even number or odd number? We have an odd number of data. Okay, awesome. So let's find the median number here. That means we're going to cross them off again. 75. Because we're left with two numbers in the middle. So we take their average, but they're the same. So that means quartile 1 is 75. Sweet. Now let's do that same process again with the upper half. So we cross off 1, 2, and in the middle. Just kidding, I did this wrong. We're not supposed to include the middle. Haha, we're not supposed to include the median. So I'm going to just do that whole thing again. You're welcome. Just extra learning. I mean, it won't change on this side. We don't include the median, so we're crossing off 1, 2, and here. 75 is our first quartile. Awesome. And then on our next one, we're not going to include the median to find our third quartile. Crossing off, 95 then is our third quartile. Hey, look, okay, we found our median. That's what they asked. That was our middle number. We found the quartile, which are like our secondary medians, the medians of the other half. Now to find the minimum and the maximum, that's the easiest thing. So we left that for awesome. Left that for last. To find the minimum, that's our smallest number. Our minimum is 60. And then our biggest number is our maximum. So our maximum is 105. We did it. Good job. Now, we're going to use these numbers later, so I'm going to leave myself a nice little hint real quick. I'm going to say, okay, the minimum is 60. Quartile 1 is 75. The median, which is quartile 2, is 85. Quartile 3 is 95. And our maximum is 105. Sweet? Sweet. Good job, guys. That was our first example. Now, that's all great, but what can we do with this information? Well, we can make what's called a box and whisker plot. A box and whisker plot is a graph that summarizes a set of data by displaying it along a number line. Box and whisker plots always look like this. This part right here is, you guessed it, the box. And this part out here, you guessed it, are the whiskers. The box and whisker. Now, what a box and whisker represents, or what a box and whisker plot takes into account, is it takes into account these 5 sets of data that we found earlier. It takes into account the minimum, first quartile, second quartile, third quartile, and max. Okay. So, I don't want to put that information there yet. I want to put that down in example 2. It's going to make a lot more sense. So what that says is we look at the median. We start with the median, and the median is this line in the middle here. we put a line to represent the median inside of our box. And then the outside of our box is labeled with our first quartile and our third quartile. Then our whiskers extend out to the minimum and out to the maximum. Okay, so we've got our 5-number summary represented in a picture just like this. Now you'll remember that the median is the middle, which means that 50% of our data lies here and 50% of our data lies within this range. Also, 25% of our data is here. 25% of our data is in the other whisker. And that leaves 50% of our data represented by the box. 100% true story. We use this all the time as teachers when we are looking at your grades. So if I want to see how you guys did on a test, for example, I will look at the median score. I'll look at how many people did, or that half the class did better than that, half the class did worse than that. So when I look at this particular box and whisker plot, that shows me that there are a lot of scores in this short range because this part is shorter than this part. These still have the same amount. There's 25% on this side and 25% on this side. So that means there are a lot of scores within a smaller range here and other scores spread out there. Cool? Cool. Now let's look at one for realsies. So we're going to represent the data in example 1 in a box and whisker plot. So our minimum score was at 60. So we're going to put a point down here at 60. And then our first quartile is at 75. So 75 is down here. That's where we're going to open our box. Again, we've got our minimum, and then we've got our first quartile. Next, we put our second quartile is the middle of our box. So we put another line here at our second quartile. And then we're going to close our box at our third quartile. Third quartile is 95. Just kidding. Our third quartile is at 95. And so we close out our box here. Now I made my second quartile line a little bit too big, but that's okay. There we go. And then finally our max is way over at 105. So now that we've got our points out, we can draw our whiskers. Oof, that wasn't centered very well. There we go. That's much better. It's our max all the way out here. Now you remember from yesterday we talked about outliers. If you have outliers in your data, they actually can extend out here, but we will not talk about what that means in this class. So if you ever see dots outside of your whiskers, that means that those are outliers. Like it's a little bit more complicated to find how to put those on your box plot. So I just won't give you outliers this time. Okay? Okay, so again, to make a box and whisker plot, start with your median, put your minimum, your maximum on the end of your whiskers, and your first and third quartile to close out your box. I was almost like, any questions? Oh, guys, I miss you. Oh, well. We'll carry on. Okay, so we started by finding our 5-number summary, our quartiles, max and min, and then how to make a box and whisker plot. Great, but what if I give you a box and whisker plot? If you're looking at it, what will it tell you? Let's use example 3 to practice. So we want to find out, what do the medians tell you about the average monthly rainfalls for Miami and New Orleans? Let's start out looking at Miami. When we look at Miami's plot, we see that its median is, what was that, 4.5? Sure, we'll go with 4.5. 4.5 inches. That means usually it gets 4.5, sometimes go down to 2 1/3 to 7 1/3-ish. Yeah. But 50% of the months in Miami have between like 2 and 7 inches of rainfall. Okay, cool. Now if we look at New Orleans, on the other hand, New Orleans plot has a median of, what is that, about 5.3? Sure, we'll go 5.3, about. Okay, so that means that New Orleans has a higher average monthly rainfall than Miami does. Or not, yeah, higher median. Okay, so typically it will get more rain than Miami does. However, looking at Miami's box plot is a lot wider than New Orleans is. That means that Miami has greater variation in its rainfall. That some months it gets just 2 inches of rain, but other months it goes all the way up to 8.5. Whoa! But New Orleans sticks between 3 and 7. So while Miami has a greater variation, New Orleans has a greater overall average. So it's important to be able to see both of those different aspects. Cool? Cool. All right. So we talked about box plots. We talked about quartiles, as you can see in box plots. We have something else that's very, very similar, yet a little bit distinct. Because when we're talking about quartiles, we are limited to just the quarters, the first quarter, second quarter, third quarter, and fourth quarter of the data. What if I want to break it up into even smaller parts? Well, I'm so glad you asked. We're not limited to 4 equal parts. We can split data sets into 100 equal parts. And when we split something into 100, we call that a percentile. Just like a percent, I'll write that neater, I'm sorry. Just like a percent means out of 100, a percentile, this is plural. Percentiles will separate data into 100 equal parts. They give us the percentile rank of a data value, which is the percentage of data values that are less than or equal to that value. Or rather, they're less than or equal to that value. For example, if you measure 500 babies when they're all 9 months old, okay, so you measured 500 babies and 375 of them weighed less than or equal to 20 pounds. That means that 375 out of 500 babies weighed less than or equal to 20 pounds. That's their key phrase here. Less than or equal to 20 pounds. So what's the percentile rank of a 20-pound baby? Well, to find a percent, we do 370. Oh, did I say 375? We'll go 375. That's fine. 375 divided by 500 equals 0.75. Exactly. So that means that's the 75th. That's 75%. So we call this 75th percentile. So if you have a 20-pound baby, which is big but not giant, if you have a 25-pound baby, he's at the 75th percentile because he is bigger than 75% of babies, because 75% of babies weigh less than or equal to that baby. That's what 75th percentile means. Let's find the percentile of test scores then. Of 25 test scores, 15 of them scored less than or equal to 85. What's the percentile rank of a test score of 85? Well, 15 out of 25 is equal to 0.6. So that's 60%. So if you earned 85 on your test, then you did better than 60% of all test takers. You beat out more than half of them. Good job. So that means you are at the 60th percentile. Fun fact, my nephew is at the 99th percentile of height of all kids his age because he's very, very tall. 99th percentile. He's taller than like 99 babies. 99% of all babies. Big kid. And I love him. He's the best. Okay. So 75th percentile means you are bigger than 75% of babies. 60th percentile means you did better than 60% of test takers. Let's circle all the way back to quartiles. Remember that your first quartile, we pick the first quartile because it is bigger than 25% of the data. It's the first quarter. So we call that the 25th percentile. The second quartile, also known as the median, we pick the median because it's right in the middle. So 50% of the data is less than or equal to your second quartile. So we call that the 50th percentile. And then finally, your third quartile is the halfway point of the upper half. So that's 75% of the data. So 75% of the data is less than or equal to your third quartile. That makes that the 75th percentile. So a percentile is like a quartile, but it's way more specific. Great? Great. So today we looked at percentiles, we looked at quartiles, and we can represent data on a box plot. This is your key idea here. Know it, love it, memorize it, write it down. It's going to be great fun. Okay? I hope you enjoy your homework.